Okay, so here we are. Hi, 6th hour honors people or other honors students.
Hello.
Hey, other honors students, say hello.
Hi, how's it going? 6 hours.
So today's an interesting day because I left my laptop at home. So I'm holding my phone right now on my computer screen. So if it's a little jiggly, I am so sorry. My arm's going to be tired by the time we're done. So we left off talking about the different considerations that we have to talk about in or use in order to decide if a certain drug is appropriate to use. Now we're looking at the adverse effects. So we had looked at the therapeutic index, right? And we talked about a higher ratio is better because we don't want the drug to be toxic to the person that's taking the drug, but at the same time, we want it to be therapeutic. So we want it to get rid of the infection. Now, sometimes people take drugs and they end up with adverse effects. So the most common one is having an allergy to the drug, like penicillin. So for some people, if they're hypersensitive to penicillin, they can actually go into anaphylactic shock and they can die. So anaphylactic shock occurs when an individual, my elbow just slipped off the desk. Anaphylactic shock would occur when somebody's throat swells up so bad that it closes off their respiratory tract and then they can't breathe.
Like when someone's allergic to peanuts?
So then they asphyxiate. Yep, that's the same thing. So if somebody's allergic to peanuts or if anybody has any kind of hypersensitivity, it's the same reaction that occurs. It's the immune system like going into overdrive.
It would depend upon the dose though, right?
But it kind of depends on the dose. But if you're taking penicillin to get rid of an infection and you're hypersensitive to it, it's not going to be good. Okay? So in terms of toxicity, there's several antimicrobials that are toxic at higher concentrations and occasionally can cause adverse reactions. So a lot of times if you're prescribed something like this, you go to the pharmacy, you go to Walgreens or CVS and you pick up your prescription, they're going to talk to you about those adverse reactions and things to watch for, especially if it's a new medication that you've never taken before. So the aminoglycosides have a very low therapeutic index. So they're not very successful at getting rid of an infection. But then at the same time, they can damage your kidneys when you take it. So that's not good for you, right? Go ahead.
Why would you even take it if it doesn't really help it?
Well, I'm sorry. I'm sorry. I think I misspoke. When I say a very low therapeutic index, that means that it's a low ratio. So it's still beneficial in terms of targeting the bacteria or microbe, but it's highly toxic to the individual, so that makes it low therapeutic. Sorry, like I said, I forgot my coffee at home today, so I'm not firing on all cylinders. I saw therapeutic index. Yikes. Those aminoglycosides or glycosides will also impair your sense of balance and can even cause irreversible deafness. So as someone, if you're prescribed one of these and you talk to the pharmacist and you decide, I'm not even sure I want to run the risk of taking this, then you got to call your doctor and find out if there's something else that you can take instead. Chloramphenicol is another antimicrobial that causes a potentially lethal condition called aplastic anemia. It's where the body is unable to make white and red blood cells. And so as you know, that your body makes new red blood cells like every 2 to 3 months or something like that. And so if your body can't replace those cells, yeah, you got to have a blood transfusion after that. So that's not good either. Usually chloramphenicol is only used when there's absolutely no other alternative available for treating that infection. Another adverse side effect would be suppression of normal flora. And we talked a little bit about this in our previous lecture, but pathogens may multiply in higher numbers in the absence of normal flora. The normal flora are those microbes that naturally reside on or in you. So first semester, we talked a lot about staph being present on your skin, E. coli in your gut, right? All of those pathogens will, what's the word I'm looking for? Compete in the ecology of your body. Thanks, Mr. Davis. I keep getting interrupted, so sorry.
Do we put a sign on the door?
Maybe we have to do that in the future. So oral use broad spectrum antibiotics sometimes develop life-threatening diseases like antibiotic-associated colitis caused by the growth of toxin-producing strains of Clostridium difficile. This organism cannot establish itself in the presence of normal flora. So it's an opportunistic pathogen. Somebody's immune system has to be pretty suppressed. And so that is one example of an adverse reaction by the suppression of normal flora. Okay? Somebody want to whisper to Amanda and let her know what's going on? Good. Speak up nice and loud.
Is the normal flora like the same thing as normal biota?
Yes.
Same thing?
Yes, same thing.
Okay.
Two different terms refer to the same thing. Microbes that live on or in you.
Okay.
Naturally. All right, so, oops, I just went backwards. So, number 7 is resistance to antimicrobials, which is kind of one of the areas in which we are going to be focused on for the remainder of the unit. In some cases, certain types of bacteria are inherently resistant to the effects of a particular drug. This is called innate or intrinsic resistance. So mycoplasma species lack a cell wall. We pointed this out the other day in lecture, and so therefore they're resistant to penicillin. Penicillin isn't going to work against them because there is no cell wall for the penicillin to attack. Many gram-negative organisms are resistant to certain drugs as the lipid bilayer in their outer membrane excludes entry of the drug. In some instances, previously sensitive organisms develop resistance through spontaneous mutation or the acquisition of new genetic information, and that's called acquired resistance. So we talked a little bit about spontaneous mutation in our previous unit, but we're going to talk, and we also talked about that acquired form of resistance as well when we talked about the methods of gene transfer in terms of transduction, transformation, and conjugation. Y'all with me on that?
Yes, ma'am.
Okay. Cost can also be a factor. So newly introduced drugs are usually far more expensive than their traditional counterparts. So increasing resistance of microorganisms to traditional antimicrobials is obviously now affecting the cost of healthcare. So that's kind of big. Now, one of the reasons that we're looking at all of these considerations is because we are focused on the mutation rate to resistance to some of these antimicrobials. Okay, so this diagram is depicting somebody is taking an antibiotic, okay, over the course of several days. Looks like 10 days to start with, okay? So at the initiation point of the antibiotic therapy, there's going to be usually fairly significant high counts or a high population of bacteria, right? As soon as you start to take the antibiotic, you should see death of that population. So it looks just like the death phase in our growth curve that we studied first semester, where it goes down. Usually there are very few resistant bacteria to that antibiotic present in the population. Now, the number of resistant bacteria is dependent on that rate of mutation to resistance. So we might find that the numbers increase during the introduction of the antibiotic therapy, mainly because those that are dying don't have the gene. Those that are able to survive, or those that do survive for some reason, go through a little bit of mutation, and we see that genetic change. That's where then we start to see an increase in the rate of, or the population numbers of those bacteria that are resistant to the antibiotic. Now, because those are present and they're reproducing, sometimes their offspring, as they reproduce, don't actually get the gene. So that's why we see sometimes an increase in even bacteria that aren't resistant to the gene or resistant to the antibiotic. So we'll have increased numbers again of both types, both resistant and non-resistant. Now, one of the reasons I wanted to look at these is because on Monday, we're going to start to look at a comparison chart. Now, I've got 4 here. You don't have to do these 4. If you wanted to, these would be the 4 easiest ones to do, to compare. So we're going to look back at our notes, and you won't be able to fill out all of the comparison chart on Monday when we start to work on this. But if you want to use just these 4, totally fine with me. If you want to look at any of the drugs from that chart that we looked at in our previous lecture, it is. No, it's not. It's on here. But that's okay. I'll give you these names again on Monday. Okay? So if you wanted to write them down, great. But if you don't, totally fine with me. Awesome sauce?
Awesome.
Awesome.
We're done.